In a Cornell competition model, we look at the quantity competition of firms when they have to decide their output level simultaneously. That is, when a firm is choosing how many to produce, it has no idea about the output levels of other competitors. And you have learned about what will happen to the market equilibrium in the previous mini video. However, sometimes the competition faced by firms may be different. For instance, due to different lags in decision making, some firms may be able to make the output decision earlier than other firms do. Similarly, an incumbent firm may be able to move first, and a new entrant will move after observing the decision of the incumbent. In these cases, firms in the market choose their output in sequence. Another model of oligopolistic competition, namely the Stackelberg model, can help us to understand more about the competition of this kind. The Stackelberg model was first introduced by Heinrich von Stackelberg, a German economist, in his book Market Structure and Equilibrium in 1934. The Stackelberg model is also called the Stackelberg leadership model. Like in the Cornell model, firms compete in quantity of output in the Stackelberg model. The difference in the two models is that, in the Cornell model, firms choose their output simultaneously without knowing what other firms have done, whereas in the Stackelberg model, there is a leader firm who can choose its output first. Then, after observing the leader's output, the follower firm decides its output. The Stackelberg competition is a classic example of a sequential move game or a dynamic game in game theory. Let's look at the simple Stackelberg model. Imagine that there are two firms in the market. Firm A, the market leader, and Firm B, the follower, and they produce identical products. The leader firm moves first to determine its output level. The follower observes the decision made by the leader and then chooses his own output. The market output is made up of the outputs of these two firms. Mathematically, it can be expressed as capital Q equals QA plus QB, where capital Q is the market quantity of output, and QA and QB represent the leaders' and followers' outputs respectively. Suppose the inverse market demand is estimated to be P equals 24 minus Q, or P equals 24 minus QA plus QB. Facing this market demand, how will the leader firm and the follower firm determine the quantity of output? To find the market outcome in the Stackelberg competition, we need to use the idea of backward induction. Backward induction is a common technique that helps us to find the solution of a multi-stage problem. It is the process of reasoning backward, from the end of a problem, to determine a sequence of optimal actions. Backward induction starts with the final step in a game, and by anticipating what the player will do at that point, the player in the earlier stage can find out her optimal action. In the Stackelberg competition, it means that the leader will anticipate the output level of the follower in stage 2, and then produce an output level in stage 1 that maximizes its own profit. Let's make a guess. How will the follower decide on the quantity of output being produced in stage 2? Right! The answer is the follower will produce an output that can maximize its own profit. We can look at the marginal revenue and marginal cost of the follower firm to find it out. The total revenue, TR, of firm B, that is, the follower, is TRB equals P times QB. By substituting the market demand and simplifying the expression, we have TRB equals 24 times QB minus QA times QB minus QB squared. Differentiating the total revenue with respect to QB, we can find the marginal revenue. MRB equals DTRB over DQB equals 24 minus QA minus 2 times QB. Next, we'll look at the marginal cost of the follower firm. Assume the total cost function is TCB equals 12 plus QB squared. The marginal cost is then MCB equals DTC over DQB equals 2 times QB. By equating marginal revenue and marginal cost, firm B's profit will be maximized. MRB equals MCB, 24 minus QA minus 2 times QB equals 2 times QB. Thus, QB star equals 6 minus 1 over 4 times QA. This equation tells us the profit maximizing quantity for firm B for different levels of QA. In other words, it tells the optimal behavior of firm B in response to different levels of output produced by firm A. As we can see, This is exactly the best response function of firm B in the Cornell model. Anticipating firm B is going to act according to the best response function. How will firm A maximize its profit? We can work out the solution by looking at firm A's total revenue and total cost. Similar to the case before, the total revenue TR of firm A is TRA equals P times QA, or TRA equals 24 minus QA minus QB and multiplied by QA. P equals 24 minus QA minus QB. In the price equation, QA and QB represent the level of output by the two firms. From the point of view of firm A, QA is the output that it would choose. But how about QB? As firm A can anticipate the output level of firm B, it knows what QB will be. So, what is QB? It will be QB equals 6 minus 1 over 4 times QA. By substituting it into the price equation, we have... Simplifying this gives P equals 18 minus 3 over 4 times QA. Notice that now the price is directly dependent on only QA, as QB is a function of QA. In terms of notation, we can write it as this. Let's go back to the total revenue function of firm A. We have TRA equals P times QA. Substituting the expression for P, we have this equation. Then, substituting the best response function for QB, we arrive at this equation. Simplifying the equation, we will have TRA equals 18 times QA minus 3 over 4 times QA squared. Notice that the total revenue now depends only on QA. Again, the reason is that QB is now a function of QA. Instead of an unknown quantity of output chosen by the competitor, the leader can anticipate QB by the best response function of the follower. We get the marginal revenue by differentiating the TR with respect to QA. MRA equals DTRA over DQA equals 18 minus 6 over 4 times QA. Assuming the same cost functions, the leader's marginal cost is MCA equals 2 times QA. And thus, the profit maximizing quantity of firm A is given by MRA equals MCA, that is 18 minus 6 over 4 times QA equals 2 times QA. And thus, QA star equals 5.14. This tells us that the leader firm can maximize its profit by producing 5.14 units of output. What will the follower do, observing the leader firm producing QA equals 5.14? In order to maximize its own profit, the follower will produce according to the best response function. QB equals 6 minus 1 over 4 times QA. And thus, QB equals 4.72. We can find out the market outcome as well as the profits for the two firms now. Q equals QA plus QB equals 5.14 plus 4.72 equals 9.86. P equals 24 minus QA minus QB equals 14.14. Leader's revenue is P times QA equals $72.68. Cost is 12 plus QA squared equals $38.42. Profit is $34.26. Follower's revenue is P times QB equals $66.74. Cost is 12 plus QB squared equals $34.28. Profit is $32.46. What kind of insights can we learn from the market equilibrium outcome? First, the Stackelberg leader produces more and earns a higher level of profit than the follower does. It implies that moving first is giving a firm advantage in the Stackelberg model. This advantage is derived from moving first observably. The leader knows that the follower's output is dependent on its output level. By anticipating the follower's response, the leader can maximize its profit by taking into consideration the level of output the follower will produce in stage 2. Second, by comparing the Stackelberg equilibrium with the Cornell equilibrium, we can see that firm A, that is, the leader firm, earns more when it can move first. It's another sense of first mover advantage. On the other hand, the follower firm is worse off comparing to the Cornell equilibrium in which firms move together. And finally, the market price is lower in Stackelberg and the total quantity of output is higher. To sum up, in this video we have: first, introduce the idea of the Stackelberg competition model. Second, work through the algebraic analysis. Third, compare the Stackelberg equilibrium with the corner equilibrium. We hope you enjoy our videos and the business competition simulation game.